This is Naveena from the Department of Cybersecurity in the Institute of Aeronautical Engineering. And several videos, and I want to discuss about the networks. And coming to the second module of Introduction to Data Link Layer. Under this, and I have already discussed in my previous videos related to that one, the services providing by the data link layer and the services which should be utilized by the data link layer, and what is the source of transmission in the data link layer from one node to the another node, and how it should be getting the services from the upper layer by means of a network layer, and how it should be consumed the services by means of a lower layer which will be collectively called as a physical layer. So now, after that, and in my previous topic, and I have already discussed related to the errors and framing and flow control, congestion control and the error control. And coming to the error correction and detection methods also I have already discussed based on that single bit error and the burst error. And according to that continuation, and today, and my topic is, I want to discuss in this video related to that Hamming distance and the cyclic codes, the advantages of the cyclic codes, and the chunk interleaving and the memory which should be related while allocating from one data sending node to the another destination sending node. Coming to that, after that, the DLC services which should be meant for the DLC layer, the sublayers of both the data link layer. The first one is collectively called as the DLC services, second one is MAC services, framing, in that framing, character oriented framing and bit oriented framing. So, and coming to the first element under this video is nothing but the Hamming distance, and which is a very important concept under the computer networks which should be interlinked or included under the data link layer. The Hamming distance is nothing but one of the central important concepts in coding for error controlling and detection. And it is the idea of what we can call it as Hamming distance, and we can define the Hamming distance in second way. It is especially meant for error detection and correcting method. Hamming distance is nothing but error correction and detecting method. And in the second way, if we can define the Hamming distance, it is nothing but the distance between the two words of the same size or the number of differences between the two corresponding bits. Suppose if you can take the example of one frame or a one bit, it can able to transmit from one source to the destination host. So we can able to calculate the mode of the distance between the two frames or mode of the distance between the two bits by means of a Hamming distance. We can able to calculate the distance between the two bits either by means of a distance mode or transmission mode, or the distance between the two frames from one source to the destination source. So we show the Hamming distance between the two words. Suppose if you can assume that it will be the x and y, as if you can assume the d of x, y, we may wonder why Hamming distance is important for error detection. And I need to explain how it will be. The reason is that the Hamming distance between the received code word and the sent code word is the number of bits which should be corrected during the transmission of data or the frames or bits from one source to the another destination source. So if you can take the example, for example, if the code word is suppose 500000 and it is about to send or ready to send from one source. Suppose if you can think here, the code word is 5 zeros and the other side is 01101 is received. The sending side is 5 zeros, 1, 2, 3, 4, 5 and the destination side is 01101 is received type. The 3 bits are in the error and the Hamming distance between the two is d of both the source side 5 zeros and the destination side 01101 is equal to 3. So in other words, if the Hamming distance between the sender and the receiver code word is not a zero, if you cannot assume or if you cannot equalize the Hamming distance between the sender and the receiver is not a zero, the code word has been corrupted during the transmission of a data from one sender to the another receiver. So finally, and I want to explain, the Hamming distance is meant for calculating the transmission of bits and the distance between the two type of frames which should be transmitted on one physical communication, or the distance between the two frames while transmitting from one source to the another destination host. So coming to the cyclic codes. What I mean by cyclic codes here, the cyclic codes are special linear block codes with one extra property. So these are, if you can define, the cyclic codes are especially meant for special linear block codes with extraordinary one extra property. So if a cyclic code in a code word is cyclically shifted, that means whether it will be rotated from one side to the another side, the result is another code word. Means, for example, if you can take the example of a 1011 000 is a code word, and we cyclically shift it from one side to the left, from one other side to the left, then it can able to translate by means of a 01100001 is also a code word. That if you can take the example and how it will be converted in a cyclic way, means here the first bit is 1, second bit is 0, and the third bit is 1, fourth bit is 1, fifth bit is 0, sixth 0, 7 0. Here the 1 should be converted into 0, 0 will be converted into 1 when it will be transmitted or rotated from one side to the left side. This is nothing but the cyclic codes, as we have already discussed. In this case, if you call the bits in the first word at 0 to 6, so how many bits will be there? There should be 7 bits will be there. If you call the bits in the first word A of 0 to A of 6, and the bits in the second word, suppose A of 0, 0, A of 1, A of 2, A of 3, A of 4, A of 5, A of 6. And if you can take the example of the second way of bits or the second code word bits like B of 0, B of 1, B of 2, B of 3, B of 4, B of 5, B of 6. We can shift these bits by using the following code word. So in the rightmost equation, the last bit of the first word is wrapped around and becomes the first bit of the second word is encapsulated. So here that condition, what we can call it as a cyclic redundancy check. Here we can create the cyclic codes to correct the errors. What is the use of main cyclic codes is to correct the errors. And the second one is wrapping up of the data and shifting the first wise of a bit from one side to the another left side. So in this section, we simply discuss a subset of cyclic codes called the cyclic redundancy check. In the shortcut way, we can call it as a CRC. Cyclic redundancy, what we can call it as a CRC, which is used in networks, which is meant for LANs and WANs. Let us see how it will be. So, we have seen that cyclic codes have a very good performance in detecting single bit errors, double errors, and as well as the odd number of errors and burst type of errors. How many type of errors it will be coming or arised while the data will be transmitted from one source node to the destination node, means there are mainly 4 type of errors we have to identify. Detecting the errors means those are nothing but the single bit error, the double means of errors, and the odd number of errors and the burst errors. So they can be easily implemented in hardware as well as the software also. They are especially fast when implemented in hardware comparatively with the software. This made the cyclic codes a good candidate or good implementation for the sake of connecting with many mode of networks. So coming to that, the checksum. The checksum is also, if you can define the checksum, it is one of the error detecting technique which will be applied while the messages are passing from one source node to the destination node. In the internet, the checksum technique is mostly used at the two type of layers, what we can call it as a network layer and the transport layer, rather than the data link layer. Why? Because the data link layer which should be present in between the network layer as well as the physical layer. So the data link layer, as I have already explained in my previous videos, it can able to utilize the services from the network layer, and it will able to consume the services from the physical layer. At the source, the message is first divided into m number of units. The generator then creates an extra m bit units called the checksum, which is sent with the message along with the transmission mode of data. So finally, at the destination, the checker creates a checksum from the combination of message and send that combination of messages to the checksum destination. If the new checksum is also zeros, the message is accepted. Otherwise, the messages will be discarded or disrupted. So example, suppose if you can see the message is a list of 5 4-bit numbers that we want to send from one source to the destination while we are under the data link layer. In additionally, to sending these type of numbers or these type of stream, we send the sum of the numbers. For example, if the set of the numbers is like 7, 11, 12, 0, 6. Here we have to see or we have to identify the 5 number of sets, the set of 5 numbers which we can collectively call it as the number wise like 7, 11, 12, 0, 6. We send this stream of data where the 36 is the sum of the original numbers. So the sum of this coming 36 is the whole sum of these numbers. If you can add it. So the receiver adds the 5 numbers and compares the result with the sum. So whenever a source needs to send this type of data to the destination, it will be having the 7, 11, 12, 0, 6, and where the 36 is the sum of all the original all these numbers consisting of the whole sum figure, what we can call it is 36. So the receiver adds the 5 numbers and compares the result with the sum. Whenever this type of bits, it will be transmitted from on one physical link from one source to the destination, the receiver assumes and the receiver needs to check whether these 5 numbers coming in the same mode only, having with the same IP address and with the same result, and comparatively the destination host need to check the whole sum of the total amount with the source host when it reaches to the destination. So otherwise there should be no error, accepts the 5 numbers and discards the sum. Otherwise there should be a error somewhere and the message is not accepted. So another point, if you have to identify or defining here, means forward error correction. That means the retransmission of corrupted and lost packets is not useful for real time. Whenever, as I have already discussed in my previous topics, there should be a flow of, suppose if you can take the consideration of n number of data bits or data frames, they can able to transmit from one source to the another destination. Meanwhile, the source node have a need to count how many type of bits needs to transmit from one source to the another destination. Suppose if you can take the example of the 5 bits, that means bit 1, bit 2, bit 3, bit 4, bit 5 from one source to the another destination. Each bit or each frame needs to hold one IP address. Each bit holds one IP address. Suppose if source needs to send from one node to the another node, all the bits source have a need to count these many type of bits I need to send from my side to the destination side. Whether if in the middle, if there is any error occurs, or in the middle, if any bit or any frame doesn't hold any IP address, immediately that bit or that packet or that frame, it will be discarded and it will be having the checksum or error detection correcting methods by means of a redundancy, and meanwhile send it to the source, retransmits it by means of a through the source nodes until and reaches its destination in a correct and successful way. So this is the one of the concepts which will be included and typically identified by means of a data link layer. So we need to wait until the lost or corrupted packet is resent. We need to correct the error or reproduce the packet immediately. Several schemes have to be designed and used in this case, that is collectively referred to as forward error correction. This technique is what we can call it as a forward error corrections. That means whenever, again I want to discuss, whenever there should be a one data frame or data bit needs to transmit from one source to the destination. Suppose 5 bits needs to send from one source to the destination. If there would be any error causing or any bit should be disrupted or any error would be identified by means of a one bit while transmitting from one source to the destination, immediately that bit or that frame will be discarded and it will be resent to the source at the source side. So again it will need to check some and analyze it and what is the type of error it would be, and again it need to transmit from that source to the destination. This is the technique what we can call it as a forward error correction techniques. That means the main motto or the main rule task performed by a forward error correction FEC technique means each and every data packet or data frame or data bit under the data link layer, it will be ready or about to transmit from one source. It will have a need to reach to the destination in a successful mode. So coming to that, for the sake of and error correcting and detection methods, the first one is, we have already seen the CRC methods. The second one is the chunk interleaving. This method, it should be proposed by the scientists known it as a chunk. So another way to achieve FEC in multimedia is to allow the small chunks to be missing at the receiver. We cannot afford to let all the chunks belonging to the same packet be missing. However, we can afford to let one chunk be missing in each packet. So let us show in the coming example and how it will be. The figure, the given below figure shows that how it will be divided each packet into 5 chunks. Normally, the number is much more larger. We can then create data chunk by original chunk in a horizontal way, but combine the 2 chunks in a packets vertically, divided by means of a horizontally and combined by means of it vertically. In this case, each packet send carries of chunks from several destination host rather than the source to the destination original packets. If the packet is lost, we miss only one chunk in each packet. So which is normally acceptable in multimedia communication. So in the given example, and I want to show the given below figure. The first one is the address bus AR. An address bus consists of the 4 type of registers AR1 and AR2, AR3, AR4. This is one of the exemplary for the chunk interleaving. And the second side of registers are the memory registers, MRs, MR1, memory array 1 and memory array 2, memory array 3 and memory array 4. And the last mode of registers, what we can collectively call it as a data bus, data registers. That means DR1, DR2, DR3 and DR4. So here the chunk interleaving means if the address bus is starting, it can have a need to wait until and unless these 4 buses reaches the destination. After that, there should be some leaving gap will be there, and there should be one time slot will be there for the bandwidth of passing the data, which I have already explained, bytes per second, BPS, bytes per second. That means after that, when the address bus is passed by means of a holding with 1 data frames along with the address registrations, after that it will have a interleaving by means of sending the memory arrays. The memory arrays for the AR1 is memory array 1. The memory array which is allotted for the AR2 is AR2, and the memory array which is allotted is for the AR3. The memory array is allotted for the AR4. So after that, there should be we have to identify the chunk interleaving whenever the memory allocated should be taken place for all the 4 type of address registers which should be mixed with the memory array. After that, there should be interleaving by means of a data bus. Those should be interleaving by means of a AR along with the memory array by means of a DR, AR2 by means of a memory array and DR2, and AR3 which should be allocated under the memory array 3 by means of a data register, and AR4 and memory array and by means of a DR4. This is one of the interleavings, chunk interleavings while you are working under the data link layer by means of one slot of what we can call it as address bus. Second slot is nothing but the allocation of the memory for the data frames or the data bits. And third one is the transmission of the data from one source to the destination host. This is one of the example for chunk interleaving. And coming to that, the DLC services. As I already explained, the data link layer consisting of the 2 sublayers, what we can call it as a DLC, data link control layer, and medium access sub layer. So the data link layer which should be present or situated in between the 2 layers. The uppermost layer is nothing but the network layer. The lowermost layer is nothing but the physical layer. So the services provided by means of a data link layer to the network layer, and the services consumed from the data link layer is nothing but the physical layer. So again, the data link layer consisting of 2 sub layers, what we can call it as a data link control layer and medium access sub layer. Data link layer consisting of these 2 sub layers, and the first layer of data link layer is data link control layer, and which is having meant for node to node communication. So whether the link is dedicated or broadcasted. So, and medium access control layer is meant for the transmission of media throughout the layers which should be present in the OSI reference model. From one layer to the another layer, the medium access layer needs to access the mode of transmission from one layer to the another layer. So coming to the DLC services of data link layer, the first part, it deals with the procedures for communication between the 2 adjacent nodes. I need to remember or remind one point here, as I have already explained, the mode of transmission under the data link layer is from node to node. It is especially meant for node to node in data link layer, that is from one source to the destination node. So, and second way, if you can define the second point, and the mode of data transmission between the 2 adjacent nodes is a full mode of communication. And no matter whether the link or a physical path is dedicated or it will be a broadcasted. The data link control, what we can call it as a DLC functions including the framing, error control, congestion control, and the heavy flow of control. So coming to the first one, as I have already discussed, framing. What do you mean by a framing? Framing is nothing but in the data, while we are working with the data link layer, the type of messages or the mode of messages which should be transmitted from one source to the destination is by means of a frames. The data which we have to identify for the sake of message passing is meant, especially we can call it as a data framing or in the mode of a frames only. Mainly the main data units, it will be splitted into the part of a frames, like which is meant especially for the easiest mode of transmission from one source to the destination host. So coming to that, the framing, the data transmission in the physical layer means moving bits. As I have already explained that the mode of transmission or the mode of data passes from one source to the destination to the network layer, we have to identify by means of a data packets, and it will be coming to the data link layer, the mode of transmission of a message or communication by means of a data frames, and coming to that below layer, physical layer, the mode of transmission or message passing is nothing but the bits. Here we have to identify one point, Data transmission in the physical layer means moving bits in the form of a signal form from the source to the destination. And the physical layer provides bits which should be synchronized to ensure that the sender and receiver use the same bits. That's what we can call it as the same bits per second bandwidth during, and the timing it will be allocated to send the number of bits. It will be essential to have a need to calculate the same number of bits to be transmitted within a mean time to the destination address. Here, and the second point is the data link layer on the other hand needs to pack bits into frames. Frames means this type: frame 1, frame 2, frame 3, like that. And why it will be splitted means these type of frames, it is especially meant for the easiest way of communication or passing the message from one source host to the destination host. So that each frame is easily distinguishable with another frame. Framing in the data link layer separates a message from one source to the destination host, and each frame packet consisting of a one sender address and a destination address. The destination address defines where the packet is to go, and the sender address helps where the recipient acknowledges the type of packet which should be coming from one source node. So coming to that, under the framing, the frames can be of a fixed. The size of the frame varies, either it will be a fixed or a variable size. In fixed size, the framings, there is no need for defining the boundaries of the frames. We can identify, there is no limit of the size. Here we have to identify under the fixed size framing. The size itself can be used as a delimiter if you can identify it here only. But coming to that, the variable size framing, and we need to define the end of one frame to the beginning of the next coming frame. Historically, the two approaches were used for the purpose: a character-oriented approach and a bit-oriented approach. For the coming concepts, and I need to explain. So the first one is the character-oriented framing. So there are two types of framings. Under this framing, there are two types we have to identify. The first one is the character-oriented, and the second one is the bit-oriented or byte-oriented. Bit-oriented. So, in character-oriented, in otherwise what we can call it as in another way, it will be collectively called it as a byte-oriented framing. A data need to be carried 8 bits format from a coding system, call it as a ASCII. And this type of framing consists of the header and the trailer. Header and the trailer. The header, which normally carries the source and the destination addresses and other control information also. And the trailer, which carries error detection redundant bits and also multiplying of 8 bits. 8 bits is equal to 1 byte, as I already knows that 8 bits, if you can define it by means of 8 bits is equal to 1 byte. So coming to that, the below figure, how the character oriented framing was possible, we can define in the coming given below figure, and it was popular where only text was exchanged by the data link layers. So the second point, if you want to define under the character oriented framing, however, we can able to send the other types of information such as the graphs, videos and the audios. So any character used for the flag could also be part of a information. If this happens, the receiver, when it encounters this pattern in the middle of the data, thinks it has reached till the end of the frame. And coming to that, the first framing concept under the division of framing, what I have already explained, there are two types of framing. The first one is the character-oriented framing. Second one is the bit-oriented framing. So coming to that, the first framing, character-oriented framing, was popularly when only text was exchanged by the data link layers. Here we have to identify the exchange or the transformation of text under the data link layers. However, we send the other types of information such as graphs and audios, videos by means of this data link layer. So if this happen, the receiver, when it encounters this pattern in the middle of the data, the things it has reached the end of the frame, it seems, until and reaches the destination host. So coming to this, to fix this problem, a byte stuffing strategy was also added to the character stuffing strategy. In byte stuffing or character stuffing, a special byte is added. We have to identify this point. And in byte stuffing or by means of a character stuffing, a special byte is added to the data section of the frame when there is a character with the same pattern as by means of a flag. That means the data section is stuffed with an extraordinary byte which is used in the mode of a character with the same pattern and will be considering as a flag. What we can call it as a flag. And this byte is usually called the escape character in some words. In a programmatically word, we can call it as a escape character and has a predefined bit pattern also we have to see. And whenever the receiver encounters the escape character, it removes it from the data section and treats the next character as a data, not by means of a delimiting flag. And coming to this is one of the example of a character oriented framing. A frame in a character oriented protocol, how it will be defined by means of a given below figure. And here the what we can call it as the flag, the second one is the header, the last one is the trailer, and here we have to identify one flag. Here in the upper layer data, it will be transmitted, about to transmit from upper layer, and the variable number of characters we have to identify here. First the flag 1 is there, and after that the flag 2 is there. Here the header, if you can assume it, a frame, I have already explained, a frame is always having the two types of formats. That means the first one is the header, second one is the trailer. In between, we have to identify the number of characters. That means the 1, 2, 3, 4, 5. So these are all we can refer to as a text character or byte characters. So this is one of the frame type example while you are working or discussing about the character oriented protocol. Here we have to, as I am already explaining you, and here the type of characters we have to identify, and a special byte or a character we need to add it to the data section of the frame when there is a character with the same pattern in the given figure, and that character what we can call it as a flag. That character what we can call it as a flag. And here the second point is the data section is stuffed with an extra byte. This byte, that character byte, is usually called it as a escape character. The character byte already in the data section of the frame, whether it will be included when there is a character with the same pattern like in the mode of a flag, that character flag what we can call it as a escape character. Escape character. So after this one, and bit oriented framing we have to identify it here. So there should be a less similarities between the character oriented framing and bit oriented framing. Here we have to see that whereas coming to the character oriented framing, and only text was exchanged by the data link layers, but here in the bit oriented framing we have to identify the bits can only be exchanged by the data link layers. However, we send the other type of information in the form of a bits, but here and we are a part of identifying the flag as well as the escape things or escape delimiters or escape characters by means of a bit oriented framing. Whether we have to identify the byte stuffing or character stuffing under the character oriented framing, while as coming to the bit oriented protocol or bit oriented stuffing, we have to identify the bits was exchanged by the data link layers. This bit is usually called it as a DLE. Here DLE. While coming to that bit oriented framing, the byte, the escape byte, what we can call it as a DLE. And whereas in the character oriented framing, what we can call it as a escape Coming to the bit-oriented framing, what we can call it as a DLE, and has a predefined bit pattern also we have to identify it. Whenever the receiver encounters the DLE in place of ESC character, it removes it from the data section and treats the next bit as a data. It will be notified, not as a delimiting flag. This is one of the example or the differences which we are talking or variated in between the character oriented framing as well as the bit oriented framing. And by this end of the video, the students can able to learn and about the Hamming distance and how there should be a need to calculate the distance between the movement of bits or a transmission of a bits or a frames from one source to the destination. We have to identify the distance between the two bits or two frames by means of a Hamming distance method. And after that, the CRC cyclic codes and advantages of the cyclic codes. And coming to that framing, in that framing, the CRC cyclic redundancy and ASCII code characters. And after that, the sizes of the framing and whether it will be fixed size or a variable size, they need to reveal or they need to identify the things by the end of this video. Anyhow, this video will be helpful and keep watching on the upcoming video. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.